Hello students, in this video also let's continue with probability chapter. Let's directly proceed with first question. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at a random from this lot. Determine the probability that the pen taken out is a good one. So let's directly proceed with the answer. Solution. So total number of pens. This question is talking about pen. So total number of pens. How much we have? 12 defective pens. 12 plus. Even this defective also, this is also under pen. So right, 12 mixed with 132 good ones. So 132. If we sum them up, then 4. We have total 144 pens. So what the question is asking, determine the probability that the pen taken out is a good one. So determine that it's a good one. So number of good pens. How many good pens we have? 132. So probability, therefore probability of getting good pens is equal to, we have 132 divided by total 144. We can cancel with 2. We can cancel with other number as well, maybe, but let's start with small number. If we cancel with 2,
then it's equal to 2 times 66, and this one 72, and we can still cancel with 2 both sides. Sorry, here 33, here 3, 1 remainder 6, and we can cut with, let's take with 2 not possible, so let's take 3. By 3 we'll get 11, and here 12.
We cannot cancel this one, so the answer will be 11 by 12. This will be the answer. Proceed with question number 2. Problem number 2 is, a lot of 20 bulbs contain 4 defective ones. One bulb is thrown from the lot. What is the probability that the bulb is defective? 2. Suppose that the bulb thrown is not defective and is not replaced. Now one bulb is thrown at random from the rest. What is the probability that this bulb is not defective? Say suppose there are bulbs in one carton, say one box. So what the question is asking, a lot of 20 bulbs. There are 20 bulbs. Okay, there are 20 bulbs. Out of 20 bulbs, there are 4 defective ones. Say suppose these 4 are defective ones, but we don't know. We'll be randomly picking up. So let's proceed. Solution number 1 for problem number 1. Total number of bulbs that is both defective as well as good ones. So we have total is 20. So what the question is asking, one bulb is thrown from the lot. What is the probability that the bulb is defective? So number of defective, question is asking about defective pens. So we have how many defective ones? 4. So probability, therefore probability of getting defective pens is equal to 4 divided by total number. So we can cancel with 4 as well as 2. So we'll just cancel with 4 1 times, and this one is 5 times. The answer comes out to be 1 by 5. Let's proceed with number 2. Problem number 2. Suppose that the bulb thrown is not defective. Say here it is thrown as, we have taken the bulb thrown here is defective one here, but suppose that the pen thrown is not defective and is not replaced. Say suppose the bulb thrown is not defective, this one again not defective one, this defective one. So here how it will be, total number of pens. Let me explain this part here. At first we have 20 bulbs, out of which 4 were defective. Yeah, fused ones, not good ones. So here the question is asking, suppose that the bulb thrown is not defective and is not replaced. So suppose we have not defective one, this one is not replaced. Now one bulb is thrown at random from the rest. Now this one you don't count this one, okay? Now total number of pens, sorry I wrote pen, it's bulbs will come out to be 19. One is gone. So out of here, total number of non-defective bulbs. So before we had 6, we are removing 1, so 16 minus 1 it's becoming 15. 15 defective, non-defective. Non-defective means good bulbs. Probability of getting a non-defective bulb is equal to number of non-defective bulbs is 15 now present. Actually it was 16, but we are minusing 1, so 15 and here total it's 19, not 20. Okay, here 19, so this will be the answer. Okay, now let's proceed with question number 3. Question number 3 says a box contains 90 ticks which are numbered from 1 to 90. If one tick is thrown at random from the box, find the probability that it bears. 1 is a 2-digit number, 2 a perfect square number, 3 a number divisible by 5. So there is a box, it contains 90 ticks. Say suppose this is ticks CD type, or I don't know what ticks, maybe this one or maybe it's different also, but let's just think this one. There are 90 ticks numbered from 1 to 90. Say suppose 1 to 90. So if one tick is thrown at random from the box, if we take out one, find the probability that it bears. First is a 2-digit number, second a perfect square number, a number divisible by 5. Here ticks may possibly not mean this one city, but I don't know. But let's not go that deep also. Total number of ticks is equal to number 1, 90. Let's go with number 1, a 2-digit number, a 2-digit number. A 2-digit number. How many 2-digit number do we have? Say suppose from 1 to 10 we have 2-digit number, so is number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, they are all 1-digit number. So then we have 10 is 2-digit number. So between this we have 10 digits. Between this 10 in number.
Between this also we have 10, 10, 10, 10, 10, 10, 10. So if we total up 1, 2, 3, 4, 5, 6, 7, 8, 80 plus 1, 81.
So we have 2-digit number, we have 81 in number. Now probability of getting a 2-digit number is equal to 81 divided by 90. We can cancel with 9, I guess. 9 9s are 81. 9 10 times, so we cannot cancel this one. 9 by 10, this will be the answer. Next, proceed with number 2. Number 2, a perfect square number. So total number of perfect square number. How many perfect square number we have? 1 into 1, 1. 2 into 2, 4. 3 into 3, 6. 9. 4 into 4, 16. 5 into 5, 25. 6 into 6, 36. 7 into 7, 49. 8 8s are 64. 9 9s are 81. 10 10 is 100. So our limit is still 90 only, so we'll stop here. If we go one more, then it's going to be 100, crossing the number. So how many we have? 1 2 3 4 5 6 7 8 9. We have 9 number of perfect square between 90. So probability of getting a, my handwriting is a bit rough, but hopefully you understand. Perfect square number is equal to 9 by total. How many we have? 90. So we can cancel it 1 times and 10 times. This is 1 by 10. Let's proceed with number 3, a number divisible by 5. Our limit is still 90, so we'll stop here. How many we have? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So total number of numbers which is divisible by 5 is equal to how much? 18 in number. Now probability of getting 18 divided by total is, we have 90. So with 2 we'll cancel it directly. 2 times is 18, this one 10. So we can cancel with 2, do 1 times, this one 5. The answer comes to be 1 by 5. This will be the answer. Okay, now let's proceed with question number 4. Question number 4, it says a child has a die box cube whose 6 faces shows the letter as given below. So face 1 is A, second B, C, D, E, A. Say suppose this is the die 3D na? A here, B here, A here, C, below D, side like that. So what the question is asking, the die is thrown once, okay, like Ludo. What is the probability of getting? First is A, second is D. So solution, total number of, let's take outcomes, or you can write phases also. So A, B, C, D, E, A, these are the outcomes. So how many are there? 1, 2, 3, 4, 5, 6. We have 6 outcomes. Now let's proceed with 1. A. How many A do we have? 1, 2. We have 2. Probability of getting a letter A, or you can write directly A. 2 outcomes is 2 divided by total number is 6. So we can cancel with 2 1 times, 3 times. So here 1 by 3. Next, number 2. D. D. How many D do we have? Only 1. So now probability of getting a letter D is equal to 1 by 6. So we cannot cancel it. This will be the answer. Okay, let's proceed with next question. This will be last question for this video. Question is, suppose you drop a die at random on the rectangular region shown in figure. This one is the figure. This is the figure. What is the probability that it will land inside the circle with diameter 1 meter? This is the total plot of land. This one. This is the total plot of land. Say suppose you drop a die at random. Says one Ludo die. You just drop it inside this rectangular region shown in figure. What is the probability that it will land inside the circle? What is the possibility that it will land inside this circle with diameter 1 meter? So the length is also not that big, 3 meter and 2 meter. So possibly it may be this much. Hopefully the size of this one. And now solution. So what we have to find is, we have to find the total area. So area of rectangle. This one is rectangular shape, so we'll take the area of rectangle. Rectangle, what's the formula of a rectangle? Length into breadth. What's its length? 3, and breadth is 2. So 6. This is about meter, so meter. So when we are doing about area, it will come out to be square. And when we are doing volume, it will come out here cube. 3 na cube. Don't make mistake here. Area will always be square. Maybe it's centimeter or decimeter or everything. Here it will be about square. Here. Now let's find out this about this circle. Area of circle. Area of circle. We have to find out. So diameter is 1 meter. If diameter is, let me write in the corner. If diameter is 1 meter, then its radius will be half of its diameter. So 1 by 2 meter, half meter. So area of circle formula is pi r square. So pi, let it remain like this, and radius how much? 1 by 2 square. So we'll write twice. Pi into 1 is pi. Here just take us 1 into 2. This one, if you multiply, 4. So this meter area, so square. Now total is 6 meter, and this one outcome, this one pi by 4. So now we have to find out the probability of landing inside the circle. So this one pi by 4 divided by total is how much? 6. So here pi by 4 here. So let's just take here 1. So if you bring up like this, it will become 1 by 6. So pi by 6 4s are 24. This will be the answer. Here it's about probability, so no need to write meter, just leave it like this. Pi by 24. This will be the answer.